Yeah, thank you so much. Really excited to be here with all of you talking about grid stability and a little bit about cannabis. I guess that's what you all came for here. Before we get started though, I kind of want to have you guys close your eyes and imagine the following scenario. Next week, Thursday, there is no DevOps days, but you're working, and at 5 o'clock when you're heading home, you will be driving in your electric car. Once you get home, of course, you need to charge your car, so you'll plug it in, and you'll start cooking your meal while you were turning on your air conditioning. Quite straightforward, right? But now, suddenly, as soon as you start cooking your potatoes, lights go out. Well, that's not an everyday occurrence, luckily, but at Enexis and a lot of people together with us, we're working hard to make sure that that will not happen. However, we cannot guarantee it yet, and that's what we're going to talk to you about. What are we doing to address that, and how can we make sure that all of you can still use the energy grid basically as we're used to. So, my name is Willem. I work at Enexis for the past 6 years already as a platform engineer, and now working as a lead engineer, as well as taking on the role of product owner for our developer platforms. Do a bit of security engineering as well, so you might see that here, because IT at a grid operator is quite vital, important. And I brought a colleague with me.
Yes, hello, I'm Arjan Mossel. I work at 20 years at Enexis, so when it's fun, you stay. I went from functional maintenance to information analytics to cloud engineering, data engineering, and now I'm product owner of the data science platform team.
So you've been hearing us mention the word Enexis, or our company name Enexis, quite a bit. Hopefully you haven't heard that much about us yet. So what is Enexis? Well, we are a network company. And a network company in the classical sense, that we build electrical and gas networks to make sure that your house is heated. We do that with quite a few people. Close to 6,000 internal, and on a day-to-day basis with some other people, we work with 8,000 to 9,000 people to make sure that the lights will stay on. Enexis is operating in the northeast and the south part of the Netherlands. So if you're living close to Amsterdam and you do have some grid issues, it's not us, sorry for that. Talk to our colleagues. No. So, a network company. That means that we are a connector in the energy chain. We do not sell any kind of energy. You have contracts with other companies for that. I'm not going to mention them because of reasons, but you know where you buy your energy from. We're basically responsible for delivering that electricity or that gas to your home. And we do that in a reasonably well way already, because the energy grid in the Netherlands is the best in the world. So that's really something to be proud of. I don't think that many people here are wondering when their next electrical outage will be, and it is because, well, our grid is as stable as it is. So in a classical sense, we used to generate electricity and gas from like big gas turbine engines, generators, and transport it over the high voltage net, operated by TenNet, something like 110,000 volts, 110 kV or 150 kV, differs a bit, transported above the ground towards more regional substations, and that's where we as Enexis take over. And Enexis is responsible for the connection to your home, and there's a smart meter at your home, and from there, it's your electricity, you can do with it. So everything in between, that's our responsibility. How many connections do we have? Because maybe you haven't heard from us, because your contract is with your energy supplier, still we're there in between. Currently, we have well, close to 3 million connections on the electrical grid and well over 2 million on the gas grid. For us as IT engineers, that means that we have over 5 million IoT devices up and running. So all of those devices stream their data, your consumption data, into an IT network so that your energy apps, for instance, will display how much you've used. That is quite a lot of information, or at least quite a lot of data parsing through, in combination with the fact that we never worry about how stable our grid is. That is due to the fact that we can offer SLAs for electrical with 4 nines, used to be 5 nines, but energy transition is going on. And for gas, or for gas connections, it's even higher. It's already close to 5, almost 6 nines of SLA. So that is extremely, extremely reliable. And this also means that we are the best grid operator in the world, which is always fun to mention, at least for us. So, an energy transition. What does that actually mean for us as a network operator? It means that we, well, basically need to expand our electrical grid quite a bit because, you know, we're moving from a fossil energy source towards a electrical energy source. Electricity is one of the most convertible energy sources, so it makes sense to use electricity for that. And as you can see here in the graph, over the past 5 years, we've already connected, or we almost doubled our capacity of renewable energy sources. So the energy transition, it's not something we're waiting for, we're actually living it. And we're doing a pretty darn good job for it if you see that we doubled that capacity and still have an SLA like that. One of the challenges is in that classical approach where energy flows from like a central place towards your home. That was always kind of the way that it flowed. Similar to internet connections where you have this main server and everything flowed basically one direction. In internet, everything becomes a microservice. Well, in our electrical grid, we're feeding in electricity in different places. That you see in the right graph. So we have over 1.1 million homes feeding in energy back into the grid currently. And that's a whole game changer for us because, yeah, it's not something that we're used to. It means that we need to accommodate for supply and demand. It makes it difficult. So what do you read about energy transition currently? I'm showing you 2 examples here. The first one is an example of even our Dutch government almost taking control of what's needed for energy transition because we want to transform quicker than we are able to accommodate. So that results in the right page. This is what is currently happening. There are waiting lists, long waiting lists. If you're a company and you want to expand, you want to have a new contract, you want to move, yeah, you have to wait for 18 months, 2 years, 5 years, sometimes even 8 years before you are able to get a connection to the grid. That is the current reality. And that is something that we are quite worried about, and we're looking for solutions for it. The reason why we have those waiting lists is because of a transmission shortage. We cannot simply accommodate this many electrical connections. It's too much. All of us are used to always getting energy whenever we want. And if we keep that model, then really this is the current reality. You will have to wait. This is an actual map. You can look it up as well. You see most of the Netherlands is already red. So wherever you want to start a business or expand your capacity, yeah, that means waiting. So what have we been doing so far? Over the past couple of years, you see an enormous amount of additional solar power. It's well over 200% of new connections, same as you just saw before. The number of EVs that are currently being charged on the grid has well, exponentially grown. Same holds for the heat pumps. We want to be able to heat houses and homes in a renewable way or with renewable energy. So move away from fossil fuels like gas and make sure you can use those heat pumps. And wind energy, of course. We all see those big parks out in sea, sometimes in the fields. That's the way that the new energy supply is going. And this is renewable, this is great, this is clean, this is mostly clean, but this is quite unpredictable. So, how to solve for it? Shouldn't be that hard, right? Just expand the grid. Just make sure that whatever you've built, double it, triple it, and then we can do anything electrical. Yeah, that's not as easy as it sounds, because the energy grid we currently have in the entirety of the Netherlands, we've built over 100 years. So if we want to double it, well, you can see that it is a lot of work. So we're limited by manpower, by resources, by cables, by money even, because it's crazy expensive. So if we cannot expand it, what can we do? Well, that capacity card that I've shown you, that was quite red, that was because we're used to always being able to get that peak power. If we do something a little bit smarter, and we cannot facilitate that peak power, because the transmission capacity was red because there are sometimes 300 to 600 hours per year where there's just way too much power draw. But that means that there are 7,000 hours where there's still capacity left. So better use the available capacity means making sure that with your customers you're able to balance supply and demand. And that means doing stuff with IT, a lot of IT. Another different or an important thing is we have to be way more transparent about what our issues is, where they arise, what can we do. That also means something that we weren't used to, because we supplied a smart meter, but you always had to contact with your energy company. Suddenly, customers, companies, they want to contact us as a grid operator to see where there is shortage. A lot of IT. To solve this, we need IT. Before I continue, short disclaimer. I'm talking about renewables. We're going to talk about DevOps, platform engineering. That means that we're going to fill this buzzword. I apologize for that in advance. Let's see by the end if we do have a collective bingo, but be aware. Then, moving to Enexis. Enexis is a company, you know, we built a grid over 100 years, worked quite well. Wasn't really that much reason to use IT in a really smart way to evolve quickly, but that changed. That changed with the need for the energy transition, and that means that in 2018 we started working with a DevOps platform. We embraced the DevOps mindset because we really felt like if you want to react quickly to the needs, you need a culture in IT that is able to accommodate and to react quickly on business requests. So DevOps, with a culture of a team, is able to build, own, and run their own application from start to finish. You know what you want to deliver to the business. You can, a classic approach is, of course, that you build some application and you throw it over the fence to the system operators, and in 2 or 3 weeks they will deploy something. Yeah, that's not something that's gonna speed up the energy transition. So, DevOps. How did we do that? Starting in 2018, we already adopted a lot of the cloud-native technologies. So everything as code. We already had the Kubernetes clusters back then. We pipelined everything. So we were early adopters of Terraform. We used configuration management. There's a whole set of tools and technologies used that we bundled together and we offered as the developer platform. And nowadays, if you look forward, that means that our IT, which used to be, you know, we used to be the Wi-Fi guys and the printer guys, we do way more for the energy transition now. You know, we facilitate, we cater, we predict. So our IT and OT is becoming equivalent to each other. We cannot have a stable grid without IT. And this DevOps platform caters towards that. So how do we do that? Well, if you ask me, there are plenty of other talks as well. Please attend for the platform engineering session after this one. But just offering one tool doesn't mean that you have a proper platform for your developers. So you need to make sure that you cater or combine certain tools and offer that as one product to your developers. Just Kubernetes is not a platform in and of itself. It needs to be more complete. So we do offer quite a few tools, and we basically namespace all of those tools together, combine it, and that's what we call like a workload. Internally, we call it a stack. That means that the team can request something like that. Everything is R-backed together. You can run your own workload in there, and you can never touch or hurt someone else, and someone else can never touch or hurt you. That means autonomy. A developer has full autonomy. Well, guardrails are in place, of course, but there is a lot of autonomy. Then we get to the point where offering all of those tools is quite hard for some developers. So you see sub-platforms emerging. They take some of those slices of this cake, or they take some of those columns in that cake, and basically productize it already a little bit. Arjan is one of the guys who is able to do that really well, and he is going to talk about how data science does that and present the 2 business cases.
Yes, thanks, Willem. At our data science team, we're one of the teams who are continuing the DevOps spirit. DevOps is the core of our team. Via the Agile Scrum way of work, we are building the MLOps, crisp MLOps process. As you can see on the picture, we see 3 DevOps types. The first is a data ops types. It's a process where we collect, transform data, and make it suitable for an algorithm or a machine learning model. Second type is the machine learning ops process, where we select an algorithm, we train it, we store it, we make it suitable for prediction. And the third process is the regular DevOps type, where we build a software solution to run our models or make predictions. When we start a use case, we start with a proof of concept. We are aiming to, with quick evaluations, achieving rapid business value. And when the concept has proven value, we take the step further to make a walking skeleton. It's a full process product, but not with all the functionality. By short feedback loops, we're trying to add more meat to the walking skeleton, as the Dutch will say, to grow to a mature product. And so we are building our products. In the data science team, we have also a data science platform team, Willem also mentioned. This platform team is providing turnkey building blocks and a base infrastructure to facilitate the DevOps teams in the data science team to make data science solutions. You see the 3 DevOps types in the picture. The base infrastructure also contains an experimental environment where data accessibility and authorization is regular with scalable compute power. When those base infrastructure also provides a standard way of testing, like integration test, unit test, security test of our data science products, and a standard way of deploying our products. So in this way, we are providing data science flavored products to the IT marketplace of Enexis. Now we have some examples of how we made business impact on the Enexis operations. The first is the upgrading of the Eindhoven grid. As we all know, climate change can cause extremely high, low or cold weather. Also, when the temperature is going low, we see peaks in electricity consumption. So combined with the generally increasing of the load of the grid, Willem already told, this can cause serious risk of the substations in the electricity grid. As you see on the picture, this is serious damage when the overloading is arriving. So there are also heat pumps in the grid as replacing the fossil heating of the households. Unlike solar panels, there is no central registration of the heat pumps. So we know there is a lot of devices with causing electricity peak values, but we don't know where. We had to analyze 22,000 substations to detect where those locations are. This is where data science came in place. With data science, with pattern recognition, we could correlate sensor data with weather data. We were able to locate the highest risk stations, and they were prioritized to upgrade at first. So this is an example where an experimental mindset has achieved business value to an Enexis operation. Let me take some water. Second example, as we announced, this is where the Sherlock Holmes part of Enexis comes in place, where we are hunting cannabis farms. I can imagine, why is Enexis hunting cannabis farms? Well, let me explain. Enexis is responsible by law for a safe and affordable connection. To comply the law, we need to detect unsafe connections and actively trace energy theft to ensure that those costs of energy theft should not be covered by the community, by all of us here. The characteristic of a cannabis farm is one, an unsafe connection. As you see on the picture, it's a very structured way of connecting. It's a web of wires, and you can imagine it's a dangerous situation. Another characteristic is it's causing a lot of electricity costs, and those two reasons is why Enexis are hunting for cannabis farms. So with data analytics of our own smart sensors in the grid, we were able to locate locations where unexpected grid loss appeared to be happening. And those locations are forwarded to our fraud department. And this is a way how we improved via the walking skeleton method to impact Enexis operations with a data-driven solution. As you heard, we use a lot of data. We have an Enexis data platform with an increasing amount of data every day. Lots of databases, lots of active teams, millions of data points added every day, petabyte a week of raw data, which is filtered 3 terabytes a week. That might not sound that impressive, but remember, it's also data points, not movies or pictures or anything. So in that case, the Enexis data platform is facilitating the energy transition by maximizing the use of data. There are some points we want to take you with your home. The first is DevOps is a culture, not a tool, not a function. You have to think how we can achieve results by experimenting, by making errors, to achieve some value.
Yeah, if you see a job opening, it says we're looking for a DevOps engineer, really ask what they mean with that. Furthermore, for DevOps to really succeed, you need to have trust between the engineering teams and your IT leadership. Because in a mature DevOps way, those teams really are self-steering. So your IT leadership is able to give you some direction, like a strategy, but it's up to the teams to decide how they get there. And that will require some trust. So if you have managing managers, don't be afraid to speak up towards that, because DevOps will not succeed if you have those.
Yes, another part is be precious of your ops part. The ops is the base of your dev. So if you don't take good care of your ops, then it will time consume and you don't have time for dev. So take care of your ops.
Yeah, that's one that we tend to forget, because it's always nice to focus on the new things. Furthermore, if you really want to achieve business value more quickly and you have this agile way of working with your company, it is really good to make a lot of errors, but you want to make the errors preferably only once and automatically test for them, so the next guy doesn't make the same mistakes or is being pointed towards it in like a couple of minutes. So yeah, be able to experiment and dare to make those mistakes. That's really, really valuable, and one of the most important cultures or aspects of the DevOps culture that you should embrace.
So we're convinced the DevOps way of work and the DevOps culture will succeed the energy transition. For my part, thanks for your attention.
Yeah.